Hello, welcome to my channel. We will be doing question number 9 and onward. Okay, so in this question we are given a function, log function, and we need to find uh, the least possible value of a. Okay, so you know that log exists only for positive numbers. We cannot find the log of negative numbers or 0, right? So it means this 3x minus 4 has to be greater than 0. It means x has to be greater than 4 by 3. So my a is 4 by 3. Okay, I hope it's clear. Okay, for your value of a, find the range of f. Okay, the range of f is from minus infinity to infinity. Okay, remember how's the graph of log x looks like? Y equal log x. Okay, uh, 1 log of 1 is 0. And when you increase x, it is a positive number. You keep increasing. And when you decrease it, it is a negative number. But it goes maximum, it goes is 0. So x equal to 0 is the asymptote. Okay. So you can see, okay. Now in this particular case, my graph is something like this. The value of x is more than 4 by 3. So this is my point, 4 by 3 here. And the graph of this function is going to be something like this. It is increasing here. Um, sorry, no, this is not right. Okay, it is something like this. Okay, 4 by 3. And uh, yes, you see, when this whole thing is equal to 1, when 3x minus 4 is equal to 1, that means x is equal to 4 plus 1, 5 by 3. So that's the point where it is crossing the x-axis. So I would say, let me call this point 5 by 3 and 4 by 3 somewhere here, 4 by 3. So 4 by 3 is the asymptote. Okay, and the graph of this function is something like this. So you can see the domain of this function is 4 by 3 and onward. So x has to be greater than this, but the range is from minus infinity to infinity. Okay, so find the range. So range is all real numbers. Okay, all real numbers for this function. Okay, for your value of a, find the expression for f inverse. Okay, when we want to find the inverse function, we need to replace y and x. So right now we have y equals 2 log 3x minus 4. So I will replace x and y. So x equals 2 log 3y minus 4, and I solve for this equation for y. So this is going to be x over 2 equals log of 3y minus 4. So if I take log x by converting it to exponential form, e power x by 2 is equal to 3y minus 4. And from here you can see 3y is equal to 4 plus e to the power x by 2, and it will be y equals 1 by 3 into 4 plus e to the power x by 2. Okay, so this is my inverse function. You can call f inverse x. This is going to be 1 by 3, 4 plus e to the power x by 2. Okay, it is given that k has two roots. Okay, so now I want to sketch these two functions. What are the two functions? One is that y equals 2 log 3x minus 4, am I right? Just want to confirm 3x minus 4, yes. And the second function is what we just found, that y equals 1 by 3 and 4 plus e to the power x by 2. Okay, so we need to plot these two functions. Okay, let me see this function first of all. If I have y equals e to the power x by 2, it is something like this. At when x is 0, it is 1. So and it is going to increase like this, and it goes towards 0. It's difficult to plot. Okay, so it's a smooth function like this. Okay, now if I make y equal 4 plus e to the power x by 2, so it is going to be 4 units up. So before it was 1, now it's going to be at 5. Okay, and it will come to 0 at 4. So my asymptote is at 4. Okay, and then finally you have y equals 1 by 3 into 4 plus e to the power x by 2. So I have to shrink it everything by 5 by 3 times. So I have the same shape, but this point is 5 by 3 and this point is 4 by 3. So my asymptote is at 4 by 3 and the graph crosses the y-axis at 5 by 3. Okay, so it is this thing. So basically 4 by 3 is somewhere here and 5 by 3 is somewhere here. So here is my asymptote. I'm not very good in freehand plot, and it is going to be something like this. Okay, while the other graph, which is y equals 2 log of 3x minus 4, right? We talked about it before that it is going to have 2 points. One is 4 by 3 and one is 5 by 3. And asymptote is at 4 by 3 and it's going like this. So again, the same things here. This point is, this is 4 by 3 and this is 5 by 3. And here I have again 4 by 3 and 5 by 3 somewhere here. So 4 by 3 is the asymptote. And 5 by 3, this is where it is crossing the x-axis. So it is going something like this, and it will intersect this previous graph at 2 points. So you can see that both of these graphs, they are mirror image of each other when we talk about the line y equal x. Okay, if I make a straight line y equal to x, so when they're reflection of each other. Okay, so this function is uh, inverse function, and this is the given function, and they intersect both with at 2 points. Okay, so this was the question. It is given that has two roots, so we have this is given to us for your value of a. Sketch the graph of this and this on this axis. Okay, label each graph. Okay, so this is f equals 2 log 3x minus 4, and this is f inverse, which is equal to 1 by 3 4 plus e to the power x by 2. Okay, label each graph, state the intercepts of each graph with the axis. Yes, we showed this 5 by 3, this is 5 by 3, and so the equation of an asymptote. Okay, this asymptote has an equation y equal 4 by 3, and this asymptote has an equation x equal 4 by 3. Okay, so these are the two asymptotes. Okay, I hope it's clear. Now, question number 10. It is interesting and challenging at the same time. Okay, so you can read the statement of the question. We need to find the area of this shaded portion. Okay, so we have to find the area of this sector and the area of this triangle. Okay, so let's see the area of sector OCD. OCD. Okay, how can I find the area of this total sector? This is going to be half, and theta and r square, and r is 4r by 3. Remember this OC distance, OC, the center of the circle with center and radius. Yeah, this is the 4 by 3. Okay, and then it is square. Okay, yeah, okay, yeah. So should I leave it as it is or simplify it a little bit? So this is going to be 16 by 2, it is 8 r square by 9. Okay, 8 by 9 and theta as well. Yes, sorry. Theta r square. I had put anyway. Okay, so this is the area of this whole sector. Now I'm going to find the area of this triangle OBE. Okay, and I will subtract the area of the triangle from the area of sector, and that will give me the area of the shaded region. Okay, now I need to find the area of this triangle OBE. Okay, so for that purpose, I need to know the base and the height. So how can I find the distance BE? Okay, in order to find the distance BE or the length BE, I will use law of cosines. Okay, remember law of cosines? It was, let me write it here, that a square is equal to b square plus c square minus 2bc into cos of alpha. So if I remove this square, it will be under root over here. Okay, so you can see this is my A, I can call it A, this is B, and this is C. Both of them are equal to R. B is equal to R and C is equal to R. Okay, and the angle between them is theta. So how would I do? It is going to be R square plus R square minus 2R into R into cosine of the angle between them. So this is 2R square minus 2r square into cos of theta. Okay, so this is, if I take 2r square common and r is outside, under root 2 into 1 minus cos theta. Okay, so this is my BE length. Okay, now I need to know this altitude of the triangle, right? So let me call this point X. So I need to know the distance OX, right? You see, this angle is going to be theta by 2 this time. Okay, so tell me what is cosine of theta by 2? Okay, sine, cosine, it is obvious it is going to OX divided by OB. Okay, so OX is equal to OB. OB is same as R. So it is going to be R times cosine of theta by 2. Okay, so knowing this BE and OX, now I can find the area of the triangle. So triangle OBE. Okay, so this triangle area of this triangle is equal to half into base, which is BE, into altitude, which is OX, right? Okay, half. What is BE equal to? BE equal to R under root 2 under root 1 minus cos theta. Okay, this is our BE. Okay, into OX, and OX is R time cos theta by 2. Okay, interesting. So this will become R square, and I can divide it by under root 2 because this half power will cancel the half power. And then I have cos theta by 2 into 1 minus cos theta. Okay. Okay. This sounds, it looks complicated, but this is going to be, it will simplify to be a very simple thing. Okay. Remember, where should I do this thing? Okay. Remember, cos of 2 theta is equal to cos square theta minus sine square theta. You should remember this thing. Okay, and this can be further written as 1 minus 2 sine square theta or 2 cos square theta minus 1. Okay, so cos 2 theta has these three relationships. You should remember it. And by the way, what was sine 2 theta? Sine 2 theta was equal to 2 sine theta into cos theta. This formula you should know by heart all the time. Okay, now I want to modify these formulas. If I replace 2 theta by theta, so it becomes cos theta equals cos square theta by 2 minus sine square theta by 2 or 1 minus 2 sine square theta by 2 or 2 cos square theta by 2 minus 1. Okay, and in the same way I can write sine theta as 2 sine theta by 2 into cos theta by 2. Okay, I hope nobody have any confusion about these formulas. So I'm going to use them. Remember, look at this one. Okay, from this formula, can I say that 2 sine square theta by 2 is equal to 1 minus cos theta? Okay, so if I take square root on both sides, it's going to be square root of 2 into sine theta by 2, and this is equal to square root of 1 minus cos theta. Okay, so what I will do, I will replace here r square by under root 2, and this is cos theta by 2, and this will become under the root and sine theta by 2. Okay, I've substituted this expression over here. Okay, now under 2 cancel with under 2, and I can write it as r square, and this is sine theta by 2 into cos theta by 2. Okay, so if I multiply by 2 and divide by 2, no problem. And you see this part, 2 times sine theta by 2 cos theta by 2, we set it over here, you see. 2 sine theta by 2 into cos theta by 2, it was equal to sine theta. So I can substitute all this, I can replace all of this by sine theta. So it's 1 by 2 r square into sine theta. Okay, interesting. So this is the area of the triangle OBE. Okay, now we have everything, and I can find the shaded area. Okay, this is equal to area of the sector, right? So we wrote the find the area sector over here. Remember, 8 by 9 theta r squared. So it is 8 by 9 theta r square. This is the area of the sector minus area of the triangle, and that is half r square into sine theta. Okay, so if you want, we can simplify and we can just take r square common outside. Inside is 8 theta by 9 minus 1 by 2 sine theta. So this will give you the area of the shaded region. Okay, interesting. It's pretty challenging, but it is interesting, I would say. Okay, now B part, we have the same diagram, but now we have to find the perimeter of this shaded region. Okay, remember how do we find the arc length? Arc length is equal to r theta, right? So what is this arc length AB? It is going to be r into this angle, right? And how much is this angle? You see, this angle is Total angle is pi minus theta divided by 2. This is the angle, right? Pi minus theta divided by 2 is this angle, and this angle is the same. It is pi minus theta by 2. Okay, so here this arc length AB is going to be the r into theta, and theta is pi minus theta over 2. Okay, and the same is over here. Okay, so the perimeter P is equal to this R plus this R. This is going to be 2R plus now this length and the same this length. It is going to be 2 times R into pi minus theta over 2, right? Now plus finally this length BE. And remember, how did we find BE? BE was found over here as this one. Okay, this is my BE. So R2 1 minus cos theta. Okay, so this is going to be R under the root 2 1 minus cos theta. Okay, so this is my perimeter. I can simplify it a little bit. 2R plus 2 cancel with 2, so this is R times pi minus theta and plus R under root 2 1 minus cos theta. Okay, this is our perimeter. Okay, I hope you enjoyed this solution. I will stop over here. Thank you very much for watching. If you ever have any question, you can always ask me in the comment section. See you in the next video.